How's it going? All right, gonna make this quick. I know we don't like really long videos, so just gonna go over some things and get you ready to roll for the test tomorrow. Again, I'll be there in the morning if you need any help, but hopefully, I think we cleared up any questions that we had today in class. Looking at the test, there is a bunch of questions that pertain to just natural selection in general. So that the idea that a population exists, and within that population there are good variations. Okay, there's good little differences, and those good variations then would lead to an adaptation. So that if an event occurs or something happens to that population, the ones with the good trait or the good variation are going to do well, survive, and then pass that on to their offspring. A lot of the questions have to do with like antibiotics, like bacteria that are resistant to the antibiotics. So there's a couple questions about that they would early on when we used antibiotics, they worked on all the bacteria, and now they don't work on hardly any. How did that happen? Well, natural selection occurred, and the original population of bacteria, within that population, there were certain bacteria that were resistant from the beginning to the antibiotics. They have in 10, 15, 20 years passed that on to their offspring, and so on and so on, and now the majority of the bacteria are resistant to that antibiotic. So there's a few questions that are pretty much that exact thing. There's a lot of questions about again, passing on the good traits to the offspring, and what's going to happen to the population in general after many years of that. Well, that trait will be more and more prominent in the population. The frequency of that allele that codes for that trait is going to go up. Okay. Something about early life on Earth. What do you think? Was there? This is number 4. Looking at that. Early life on Earth, was it, multicellular organisms all over the place? No, it was probably single-celled organisms first, okay, and then multicellular, and so on and so on, okay. Fossils, okay, there's some fossil questions. So if, there's a fossil down here, the lower fossil, and then a fossil up higher. Obviously, we know the one higher is younger, the one lower is older. But the other thing you need to realize is, if these two fossils show similarities to each other, then this one, the one up higher, probably is a descendant, okay, of this one. So this would be the ancestor, the lower one down. The one higher up was probably it came from that earlier one. So that's another thing you need to realize. Then again, there's a couple questions about that, about the layers of fossils, and if they came from each other, that would be a relative easy thing to think about. If you're watching the video, you're actually going to get an actual answer. Number 9. Okay, number 9. We talking about it kind of explains what this idea of the founder effect is. Okay, and then you go through, and the answer, freebie, is C. Okay, number 9. So there you go, just for watching. Don't forget reproductive isolation. That's the idea that a species is separated for whatever reason and they cannot reproduce anymore. So there's a couple questions about that. Reproductive isolation. It's a geographic, could be behavioral, but for some reason they're separated from each other and they can no longer interbreed. And so eventually that leads, reproductive isolation will lead to the idea of speciation. Okay. So make sure you remember that. There's another antibiotic one. There's another fossil one. Gene frequency. Okay. Another one about DDT, about a poison in mosquitoes. It's the same idea. Some mosquitoes were resistant to the DDT in the beginning, and over time, they passed that resistance on to their offspring. One about the moths. Okay, so you make sure you look at that one. About woolly mammoths and these other species of mammals most likely exist today because, unlike the mammoths, what were they able to do? They had certain inheritable traits that enabled them to survive. Sounds good to me.
Daddy!
What, Carlin?
I have to show you something.
Okay, hang on. Daddy's right in the middle of something, okay? Let me finish this up. Another question here, number 24. Okay, it shows some bugs. One time they're a certain color, and another time they kind of change colors. Why do you think that change in that bug population occurred? Probably because something in the environment changed, kind of like the peppered moth lab we did, where the environment changed and all of a sudden the predominant color of moths changed from the light colored moth to the dark colored moth. Okay, so an environmental change. Dark colored moth, light colored moth. You got it, sweetie girl. Disruptive selection. Okay, remember, disruptive selection is the type of selection that selects the two extremes of a trait. So disruptive, if you have short neck giraffes, medium neck giraffes, and long neck giraffes, disruptive selection is going to select for the long necks and the short necks. So it disrupts the population. It disrupts the norm of the population. Natural select, just in general, natural selection produces change. Natural selection operates extremely rapidly to develop advantageous traits. And so how could natural selection make things go really, really fast? Okay. Basically, the idea there would be populations that are facing a change in environmental conditions. So if there's a big change in environmental conditions, natural selection could act pretty quick. No, leave that pillow in here. A graph, which species is better adapted to the environment? The one that's going up, obviously, the population that's growing. Another natural selection question about squirrels and how they're changing. And that's it. Like I said, a lot of natural selection questions. You should be good to go. Just you got to read careful, take your time. Again, I'll be there in the morning, and that's about it from me this evening. I told you, short video, and hopefully it helped and got over the stuff you needed to go over. And you want to say bye? Say bye, Carlin.
Bye, Carl. Bye.
Bye. All right, we'll see y'all tomorrow. Study hard and good luck.